Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 25th, 2025, which was about 7 days ago. The standout result is a dynamic data mixing method that boosts downstream scores, with TiKMiX-M averaging a 2% gain across 9 benchmarks and TiKMiX-D beating RedMix while using just 20% of the compute. The paper is titled, TiKMiX, Take Data Influence into Dynamic Mixture for Language Model Pre-Training, and the implications for model training are quite significant. In short, it introduces group influence to track domain value efficiently, then optimizes or predicts better mixtures as the model evolves. Alright, Figure 1 shows that TiKMiX consistently ranks at or near the top across 9 benchmarks, which means dynamic mixing delivers broad gains rather than niche wins. The radar chart compares TiKMiX-D and TiKMiX-M against RegMix, Do-Re-Mi, Quad, PyLCC, and a human baseline. Scores rise outward, so the larger pink and orange polygons indicate better average accuracy. Notice the bigger spans on ARC subsets and PyQA, which signals stronger reasoning and common sense improvements. Alright, Figure 2 shows a feedback loop that adapts the training mix, so the model keeps learning from the most useful domains. Group influence means estimating how much each domain would improve validation scores if upweighted, which is like asking which ingredient most boosts the recipe. The pipeline measures influence, then either directly optimizes ratios with TiKMiX-D or predicts them with TiKMiX-M and updates the next training stage. So Table 2 shows that group influence lets the method read model preferences accurately with very little data, which means faster and cheaper scheduling of the next mix. The comparison contrasts a simple loss heuristic against TiKMiX-D using only 0.1 billion tokens. Scores rise consistently across MMLU, ARC, and PyQA, so the average jumps by roughly 1.5 points. This matters because tiny influence probes, not proxy model training, already deliver reliable guidance. So Table 1 makes the headline concrete. Dynamic mixing lifts accuracy across 9 benchmarks while keeping compute modest. The table compares baselines against TiKMiX-D and TiKMiX-M, which are the direct optimizer and the surrogate search, across in-domain and out-of-domain tasks. Average performance rises and wins cluster on ARC and PyQA, which signals stronger reasoning and common sense. Compute cost stays competitive because the method avoids training proxy models. Wrapping up, 2 takeaways stand out. Dynamically adapting the training mix with group influence delivers broad, reliable gains, and it does so efficiently because tiny influence probes replace costly proxy training. The broader implication is practical. Curricula for massive models can be data-driven, stage-aware, and compute-frugal. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.